this video will explain about normal distribution. Normal distribution, when a random variable x has a normal distribution with the mean and the variance if and only if its probability distribution function is given by the function of the distribution 1 over square root of 2 pi sigma exponential power of negative 1 over 2 x minus mu divided by sigma power 2, where x is in element of R, mu in element of R, and sigma must be greater than 0. And it is denoted by the x is normally distributed with the mean and variance. So here is the bell shape of the symmetric normal distribution, where you can see that the center here is the referred to the mean, or the peak referred to the mean, and then the range here is sigma must be equal. So this is a symmetric bell curve. A normal distribution when plotted give a bell shape curve such that the total area of the curve is 1, means that the area under the curve is equal to 1, and the curve is symmetric about the mean. Here is the center is equal to the mean, and the two tail of the curve extend indefinitely. So as you can see, the curve here will extend indefinitely to the right and to the left. Next is the area of the curve between two coordinates x equal to a and x equal to b, where a less than b represent the probability that x lies between a and b, denoted by the probability between a and b. If x is normally distributed with mean and variance, then the random variable of z is x minus mu over sigma is normally distributed with the mean 0 and the variance 1. The random variable z is called as the standard normal distribution with probability function 1 over 2 square root of 2 pi exponential negative 1 over 2 z power 2, where z is in element of R. And the curve is symmetric about z equal to 0. So this is the standard normal curve where the curve is symmetric about z equal to 0. In the normal distribution tables, the partial areas under the normal curve are tabulated against the standardized variable z. So let's look into the example. Given a standard normal curve, find the following probabilities: A, B, C, and D. So let's go to the first one. Probability of z from 0 to 1. So here, if you want to find the probability of z from 0 to 1 based on the curve in the table, you need to, it is actually equal to probability of z greater equal to 0 minus probability of z greater or equal to 1. How do I get this? Okay, refer here. So if you want to find the probability of z from 0 to 1, so the area under the curve is like this. Since this is standard normal curve, so the center is 0. So from 0 to 1, so the blue color here is the area that you want to find. All right, so first, you look into the area probability of z greater than 0 here, from 0 until the indefinite, minus probability of z greater or equal to 1. So if the area under the curve greater than 0 minus the area under the curve greater than 1, you will get the total area of z between 0 to 1. So based on this, you need a statistical table to refer what is the value of probability z greater or equal to 0. So based on the statistical table here, as you can see, the value of z is greater or equal to 0. So it is equal to 0. So here, the value of z in the first column, 0, and then at the row, you need to refer also 0 because the value of z is only 0. Therefore, the value of probability Z greater or equal to 0 is 0.5. So based on the normal table, probability of Z greater or equal to 0 is equal to 0.5. Next is, what is the probability of Z greater or equal to 1? So find the first column here, refer to 1, and then here is only 1, so 1.0. The row is 0. So the value of probability greater or equal to 1 is 0.1587. Then substitute the value 0.5 minus 0.157. Then you can get the answer is the probability of Z from 0 to 1 is 0.3413. Let's look into the next example. Probability of Z between 1.5 to 2.15. Since this is the continuous variable, so it doesn't matter whether it is half equal or not equal, because the table is only value greater or equal. Alright, so based on this, this is the area under the curve that you want to find between 1.5 and 2.15. So you can see that we need to find the value of area greater than 1.5 minus the area greater than 2.15 in order to get the total area of 1.5 to 1.25. So based on the statistical table for 1.5, all right, the row of 1.5 and the column is 0, you will get the probability is 0.0668. And then 2.15 is 2.1 from the row, and then go to the column 0.05. So the probability is 0.0158. Then you just substitute 0.0668 minus 0.0158. You will get the value of probability between 1.5 to 2.15 is 0.051. So the next question is negative. As you can see, the probability of between negative 0.75 to negative 0.25. So as you can see, based on this table, this curve, it is located at the on your left. All right. So it is actually equal to the right hand side, because in the statistical table only measure the positive value. All right. So for positive value is actually the area between 0.25 to 0.75. Hence, in order to find the area between 0.25 to 0.75, you need to minus the area of greater 0.25 minus area greater than 0.75. So by using statistical table, 0.2 and the column 0.05. So the value is 0.403, and the next is 0.75. The value is 0.2266. Then you just substitute 0.4013 minus 0.2266. The answer is 0.1747. And the last one is the value, the probability between negative 0.15 to 1.25. As you can see, it is combination from negative value to the positive value. So based on this, we know that the total area under the curve is 1. All right. So in order to find the area between negative 0.15 to 1.25, the whole area minus the area greater than negative 0.15 minus the area greater than 1.25. So based on the statistical table, we know that the statistical table only measure the positive value. So probability Z greater than 0.15 is 0.4404, and probability of Z greater than 1 to 5 is 0.1056. Then the total area between negative 0.15 to 1.25 is actually 1 minus probability Z greater than 0.115 minus probability Z greater than 1 0.25. So the answer is 0.5454.